Good morning, everyone. I'm from Sydney University, Australia, but I'm originally from Korea, as you can recognize from my surname, Kim. It's really great to see you all here in Seoul, and it's nice to see my past colleagues. We spent some formative years together, Professor Young-Wan Cho and I. I'm so proud of that. I spent my 20s, my formative time at Seoul National University. It was a great place to be, and I had a great time of learning here. But in 2010, under the snow, it was a really stormy day with heavy snow. I left South Korea in March 2010 when I took up a lecturership at the University of Sydney. It was a great opportunity to take on, but I also had a lot of fear whether I will be able to really adjust myself to the new environment. There were a lot of difficulties, challenges, of course. Also, there were a lot of oppositions to what I wanted to do. But between my husband and myself, we built a distinguishable really approach to teaching and research on science of learning. And the biggest achievement we so far has made is the publication of this book, The Science of Learning and Development in Education. This book was written to introduce science of learning and development. I always added the word development here, to the pre-service teachers. What we believe is that any teachers, any educators who will work with the children, adolescents, and also adults should know how they learn and how they develop. That is the core knowledge every teacher should have. But sometimes that is not well recognized in the teacher education program. We often jump into the how to teach and how to use technology. But at the core, everyone should know how children and adolescents learn. But just knowing how they learn, how they develop is not sufficient. We need to know how children's, adolescents' brains are enabling their learning and what they do. So since 2010, when I took up my lecturership at the University of Sydney, I incorporated brain science and educational neuroscience as a part of the pre-service teacher education. So when I took up 2010 lecturership, I had to teach 500 students in my large cohort of this class, and everyone had to learn how memory is formed, how emotions are made in the brain, and that was the part of their core learning. And now at the University of Sydney, we have a master's class of educational neuroscience in context. So now this textbook I have written is the core textbook every master's students in educational psychology should master. And also many teachers who are in their actual service come to my class to learn educational neuroscience. Well, it sounds all good, but I have brought some bad news for you. I hope I am able to give more answers than questions, but I might end up with more questions to you today. There's some problem. Education is full of theories. Now education theory is in chaos. Education theory, you can name a few. Constructivism, information theory, information processing theory, social constructivism. There are lots and lots of theories, and over the past 100 years, we just added, and now we are facing a kind of chaos. So here are lots of lists of names of the theories you are aware. Some are coming from 1960s, 1970s, and 1980s. But we just consider them that they are having some kind of equal status. They just are used in many different occasions, and we sometimes adopt different theories according to the needs and our perceived usefulness of them. And there is another theory called social cultural theory from 1930s. Of course, Vygotsky's work, David from NIE, mentioned Journal of Proximal Development, had made a great contribution to our acknowledgement of our social dimension of cognitivism, and also the relationship between teacher and students. However, this is now rather misused. It is taken up by some of the postmodern ideas, and it gives away some kind of a comparison between theories, and then gives some kind of a relativist viewpoints. And in the Western countries, this kind of idea is now leading to anti-scientific viewpoints. That is very problematic, particularly to us, because we want to take science of learning perspective. We want to bring the science back to education, but in some parts of the Western countries, they are anti-science movements. So they are actually against education researchers to bring science back, and particularly brings educational neuroscience into the research area. So, is that the only problem? No. Now these chaos bring even bigger problem. Now we are trying to move ahead, move forward to the science of learning, but we can't make consensus about what is really the science of learning. So some say there are some 43 different distinctive definitions of science of learning. Even more confusion, even more chaos. That is the result of this chaos of theories. We, within educational research sector, we just added and added new theories and did not really think about which is better than others, which is more comprehensive than others, and which is really in line with other sciences outside of the education. So here's one example of a publication which reports that there are multiple different unique definitions of science of learning. So this study analyzed some 50 different documents, and then they reported that there are 43 completely, starkly different definitions of science of learning. So how can we solve this problem? We really need to solve this problem if we really want to move forward within this area of science of learning. Well, then does science of learning mean evidence-based teaching and learning? Some people use the term science of learning as equivalent to evidence-based teaching and learning. But I dare to say, no, I want to insist that science of learning is not evidence-based teaching and learning. Once upon a time, humanities believed that Earth was the center of the solar system. That was evidence-based. Why sunrise in the morning and sunset? We can still explain with Earth-centered viewpoints. It is evidence-based. In education, evidence-based is often used, but it opens up doors again to all of the previous 20th century theories because they are still all evidence-based. So main problem is that the notion of evidence-based teaching and learning approaches sets the empirical bar far too low. So being evidence-based is just a very loose and permissive criteria to say somebody is doing science of learning. Even very bizarre and problematic theories can become still evidence-based. It is not very popular in South Korea, but some in Western parts of the world, one of the popular ideas, mistaken ideas, teachers pick up is something called learning styles. There are visual learners, there are auditory learners, there are kinesthetic learners, so we have to design learning experiences to suit their own unique learning styles. That is a mistaken idea coming from modularity ideas in neuroscience. But they're still evidence-based. If you believe in that theory and design a research and collect data, they can still find the data that confirms that theory. So just being evidence-based is not good enough to be learning science or science of learning. So by science-based learning, I don't simply mean evidence-based. We should pursue something above and beyond. We have to use much higher threshold or bar. So what I'm saying then, what is really science of learning? Well, some of you may not agree with me, but by science of learning, I say it is a science of a complex dynamic systems that typifies human brain. There are different kinds of systems, but there's a complex and dynamic systems. And our human brains, our human society are such a complex and dynamic systems. So science of learning needs to embrace the science of a complex and dynamic systems. And also, the neurobiology of learning and development should be at the core of science of learning. When I say neurobiology of learning and development, that means complex, dynamic brain connectivity. But this brain is not something isolated, doing their own computations. They are embodied, they are part of the body. They are always receiving feedback from our sense organs, bodies, monitoring feedback, and they are physically, socially embedded and predictive brain. Brains are not always waiting to receive some kind of a sensory data from our bodies. It is much more proactive. We have to start from there to our design approach. And also, another important thing is that science of learning should make very effortful reflections on the philosophical and educational issues that arise. When we bring neuroscience into the education and also technology into the education, they open up new ethical, also philosophical problems. So science of learning should tackle with these kind of problems effortlessly. And what is important about this definition, particularly for this conference, is that it aligns directly with the brain science that underpins the currently very successful development of AI. Do you recognize the person on the left hand of the screen? The Geoffrey Hinton, Nobel laureate, the godfather of AI. How was he able to succeed with his attempt to design such a powerful AI system? He relied on the brain science. He thought we have to design a system which copies the way our human brain works. He did not start from somewhere else. He started from brain science. So he was interested in developing artificial intelligence system that has a kind of neural connections like ours. He did not start from the serial computer model. It is complex, dynamic, and self-organizing emergent system which is dependent on massive connectivity between neurons and between neuronal pathways. So physicists and computer scientists, to build a learning machine, they went back to neuroscience. That's what I believed we should do in education. So I took our potential educators' attention back to neuroscience. But that is not what is happening in every part of the world. Still, 20th century theories of cognitivism is still taught to the educators. We need to help them understand how human brains learn to really equip them with the necessary toolkits and strategies. So, education theory in the era of AI. Well, now I think I should go to a little bit more controversial bit with this part. My question are like this. What are we going to do with AI right now as it enters education globally? We have some colleagues here who are enthusiastic and want to augment human intelligence in collaboration with AI. Yes, I appreciate that. I also think that it's necessary. But we have a chaos here. So if we look at this diagram, here is AI coming into the pot. But within this part, we had a lot of ingredients. The theories of constructivism, social constructivism, and information processing theory of cognition, which is basically is about serial computer model of human cognition. And also there are lots of other theories of learning. And also there are lots of different intelligence theories within education. So within this melting pot of chaos, shall we just add AI into this melting pot cauldron? Is that what we want to do? Are we going to add it to the current chaos, making more chaos? Or are we going to grasp the nettle and are we going to face the facts that we need to sort out this cauldron melting pot or perhaps get rid of this melting pot? There are some ingredients now, they are outdated there. Perhaps we need to sort out them first before trying to add AI into the melting pot. So my answer is that I want to suggest we get rid of this cauldron melting pot first. I can see some of the audience here feeling very unsettled with my answer. So I don't want this chaos of education theory. Let's get rid of this one. The theory should enter the 21st century first. That's how our AI system, generative AI system, is currently available. They did not accept previous ideas of how human cognition, There was a belief that children are born with language acquisition system, something inbuilt already in the beginning. But Jeffrey Hinton did not adopt that. He laughed at Noam Chomsky, upsetting Noam Chomsky very much. But he was right. So we can't just add more and more theories, which is now somewhat outdated. We have to get rid of it. And what I would like to suggest is that a major implication of AI in education is actually giving us this opportunity to do. So AI in education, I believe, should bring a major shake-up of education theory, and also it should bring a major shake-up of what teachers are taught in teacher training and what they are required to know. That's what I would like to see with the advent of AI in education. So, I have this kind of a model about what professional teachers need to know and learn. This is rather similar to David's model of a diagram. So they should have a firm grasp of subject contents knowledge and research-informed imaginative teaching skills and critical literacy of technology and machine learning in education, and also sound scientific understanding of how children, adolescents, and their brains learn. But I have a different value for the last bit. I believe this sound scientific understanding of how children, adolescents, and brain learn should be the basis of all other aspects. Imagine somebody is in science education degree, physics. They should learn highly abstract concepts and theories of physics. But how do children learn to understand abstract ideas? Already developmental scientists know how brains enable the learning of abstract concepts. And also we even know that how brains are changing when children are learning the abstract concepts and what makes difference to the quality of the concepts they learn. And we can look at even at the brain neurobiological level. And same, how to teach should be informed by how children actually learn and how they develop. So the last bit is the basis. But I have a rather different relationship between the last bit of development and critical literacy of technology. I believe they should be working in hand. So it is not only developmental knowledge supporting teachers, ICT or AI literacy, but also use of AI should contribute to teachers' growing understanding of how students learn. So they should be in mutual modification between two of them. So by engaging with AI, teachers and students can learn what are about being humans, how human learns. So AI should assist teachers and educators' understanding of how students learn also. So 6 key messages so far is that education theory is in chaos, and there's a kind of a melting pot, conceptual clutter in education sector. Over the past 30 years, abundance of new insights have emerged from the science of a complex system and mainstream neuroscience. So now it is time to embrace them and then check whether our past theories are all up to date. An arrival of AI brings 2 issues into the sharp focus. First is that it is not acceptable to simply add machine learning or AI as another ingredient to the melting pot. And also every teacher in school worldwide should have a sound scientific understanding of the science of learning and development as a hallmark of their professionalism. And fourth key message, the science of learning and teaching, I don't mean evidence-based approach that is very loose, easy to pass. But it is essential that in the context of education, this new science of learning and teaching is not conceived as emotionally detached or values neutral, rather it should emphasize that all learning and thinking is laced with emotion, value, meaning, and salience. They are the core, they are the contributor of the changes of a brain's connections. And the last point so far is that all of this taken together provides a new and highly productive way of seeing the neuroscience of learning and teaching working in mutual modification with the introduction of machine learning and AI into the classroom. Though we need to be very clear that AI poses problems of its own in educational contexts. So, how do we apply these ideas in Sydney? Okay, so here are some pictures from Sydney with my PhD students. So at the heart of our work, we would like to know how children's and adolescents' brains are learning in collaboration with the human world and also technology. So we need to access human brain, so we use electroencephalography to monitor real-time activities happening in human brain. So we take electroencephalography to the schools. So you see there are children doing some kind of mathematical activities with the cap on. We actually go to the classrooms, so we go to the schools. So we work with the schools in collaboration. Our design of the research actually is very much in partnership with the schools. So we work together with a lot of school leaders as well. So at the bottom, I have pictures with one current PhD students and one past master's students. They are all leaders in independent school sectors in Australia. They are very willing to embrace these new ideas. They would like to help their teachers in independent school sectors to gain this professional knowledge. And also we have a successful completion of a PhDs. So we are quite successful in this regard. We are currently generating next generations of science of learning leaders in educational research. So we have done quite a lot of work so far, but we have one core question. It's always important to have a good question and good theory, and our focus currently is all about what does the predictive brain tell us about error, feedback, moral values, and emotions in the process of learning. Human cognition in 20th century, if you look at some of the textbooks in educational psychology or learning theories, you will find there are kind of a serial computer model, but now this is outdated. The brain is much more proactive, and it is always making prediction about what will come next. This is a very different idea from 20th century cognitivism theories. In 20th century theory, always cognition waits to receive data. But human brains, children's brains, they are always generating prediction about what will come in next a few seconds. So, neural conversations, they always try to anticipate what kind of data will come in sight or in the taste or touch. They're always waiting and making predictions. And when there is a discrepancy between brain's prediction and outcome, there are kind of a prediction errors that is perceived by the brain very quickly. Sometimes the students do their task and make mistake, and then they realize that, oh, I've got it wrong. But before they have that awareness, actually, brain makes its own awareness within just some 50 milliseconds. And then human awareness of error making comes much later. So brain is always trying to make a prediction, and it detects prediction error very quickly. So human brains are far more proactive. But there's some problem. Some of the ideas in 20th century did not really embrace or did not have awareness of this idea. And some of the cognitivist ideas in education just developed without any awareness of human proactive, predictive brain. So some of the documents, like this one from the UK, and also there are some other documents in Australia, there are some ideas about how human cognition works, how human learning is happening. But now, if we look at these ideas from 21st century understanding of how brain works, they are not actually stacking up. So they are questionable. So last year, my PhD students and my husband and I wrote a paper, and it was published in December. It is titled Beyond the Theoretical and Pedagogical Constraints of Cognitive Load Theory and Towards a New Cognitive Philosophy in Education. I know that cognitive load theory is very famous in educational technology field, and everyone is so much interested in how to measure cognitive load. But we question, is the load really important? Does load really exist? So since we published that paper, there were lots of calls to hear from us. So we once had a meeting with the Berkeley team, and also we were invited to talk with the teachers in the UK, organized by leading independent schools, HMC Society. And also our paper is currently most read paper within the journal. We can actually see that human brain is very proactive. Something people are delighted with generative AI is that they can provide very quick, real-time feedback. We love feedback. We love giving feedback. But whether feedback is useful or not, if the learners are not really ready to receive feedback, they are useless. As I told you, human brains works much proactive. Some brains are much more ready to receive feedback, and some are not. And that makes difference to the extent of encoding the feedback message. And what we found is that is actually related to their academic performance. And also proactive brain also appraises messages. And how brains are dealing with exactly the same message can bring exactly very different emotional experiences. Some students feel feedback are encouraging, useful. Some students feel, no, I don't want to really receive that immediate feedback. That is very stressful. That difference is also coming from what our predictive brain does. So we can learn how human moral decision making is made by the predictive brain, and these differences in predictive brain can make actual difference in real world social engagement in moral world. And what is important is that what parents do, what we do in social environment actually build the brain which generate predictions in certain ways. I can talk more about this detail if you are interested in, but time limit does not allow me to go more. So lesson learned so far is that all learning thinking is laced with emotion. They are so important, but some of the old cognitive theories in education distort educational researchers' understanding of human learning. And the capability of a current LLM-based AI, they are wonderful, but they have not really reached the capacity of a proactive, predictive human brain. Also, human brains are very much emotional and value-oriented, reflective, but AI still does not have that function yet. And also, we have to think about ethical questions, particularly when we consider what is happening in the brain, what AI is doing to our children's and adolescents' brains. And we need to be very clear that AI not only presents learning and assessment problems, and also it poses distinct ethical problems in educational contexts. So in the Western part of the world, there are a lot of concerns about using generative AI in education sector. We feel that some of the humanity is ripped off, and actually students are not happy. They think actually their professors are not doing their job, so they ask, why should we pay full fee when teachers are providing an AI-generated models? So the key message is that education theory is in chaos. It is not acceptable to simply add machine learning as one extra ingredient into the witch's cauldron. The cauldron, the chaos melting pot should go first. And science of learning is not evidence-based. It is above and beyond. AI in education should bring a major shake-up of education theory and a sound neurobiological appreciation of how the human brain learns. And don't let the machine define the boundaries of what the predictive and value-oriented human brain does. Thank you very much.